Hey, it's Kley. Welcome to another video. This is going to be an update on my 6AU6 Princeton build. In this video, I want to kind of talk through some of the initial decisions that I made and why I came to some of those conclusions. With this amplifier build, my intention was to be a little bit more creative with my design choices and kind of taking a set of components from scratch and figuring out how to make an amp work out of them. So, I got some great help here from my thread at TDPRI, so please check that out. But some of the things I want to kind of point out as I go. So this is actually my initial schematic. So once I kind of had the parts put together and participated with some really helpful discussion on TDPRI, I drew a schematic. And I just kind of want to talk about some of my initial thoughts. So first and foremost, when you're designing an amp, you need to take into consideration the power supply because that really identifies some of the variables that you'll have to work with later on. So this is the eBay auction from the power supply that I bought. And we get some information here that's helpful. I'm taking all of this at face value, but really need to test it once we get going. But kind of just making an assumption here that all of this is true and correct. So we indicate here that it drove a single 6L6, 3 12AX7s, one 12AU7, one 5Y3, and one 6E5. But I also indicated it will power 6V6 5E3 type push-pull. So that's helpful. Then, he tested the transformer. It reads as follows. So this is really helpful information. So this 400 center tap 400, that is our high voltage secondary output. And this is really important because this will dictate the kind of tubes we can run. Then we also have 220 milliamps of current, also very important for the types of power tubes and the tube complement that we could run off of the high voltage tap. Then we've got a 5 volt high tap here. That is essential because 5 volt tap is our filament requiring for a tube rectifier. So, and we also have a 2 amp current coming off the 5 volts. So that basically, if we go to this discussion here on TDPRI, you can see this Commodore 64 very helpful, indicated with only 2 amps on the 5 volt tap. We're limited to the following tube rectifiers. So those are my choices with when it comes to tube rectifiers. Now let's go back. Then we also have a 6.3 volt center with a center tap. That's our filament winding. And we got 4 amps of current, and that will kind of dictate how many tubes we could run. So with 4 amps of current, that's, I think, kind of a lot. If we wanted to run like a reverb or tremolo drivers, we probably could. But then let's go back up here to our 120 milliamps at 400 center tap 400. So first of all, the 400 center tap 400 is really important because it will determine that we really can't run like an EL84. That's going to be too hot of a plate current at 400 volts. But then 120 milliamps is kind of a low current to run things like an EL34 or a 6L6. So basically our only viable choice here is going to be a JJ6V6 because it will handle the higher voltage, but it doesn't require as much current as some of those larger tubes. So, and that was really helpful from these gentlemen. Again, at 120 milliamps of current, we really can't run 6L6s or EL34s. But then also with 400 volt center tap, we really probably can't run, anything like an EL84. So we got some really nice estimates here as to where that information is coming from, so check that out. So taking that into consideration, my power supply, I'm going to run a 5Y3 tube rectifier with 6V6s in push-pull configuration. So basically stealing the power section from a 5E3 Tweed Deluxe. So that's kind of what you see here in my schematic. We got our 5Y3 rectifier. Now, let's run some discussion as to how I want to run the rest of the circuit. We've got our push-pull 6V6s. Now, I chose to set them up in fixed bias. So what that means is if you look here, this is the, let's go ahead and zoom it in on these push-pull 6V6s. So this is the cathode coming out of the 6V6s, and you can see it's going directly to ground. Whereas over here on the grid, through this 1.5K resistor, I've got this bias circuit in here, providing our negative voltage to bias the tubes. This is a fixed bias configuration, and all their alternative would be cathode bias. that would mean there would be a resistor and possibly a capacitor here on the cathodes that is biasing the tubes, basically exactly like you see over here at a preamp tube, where you've got the cathode running into a resistor and possibly a capacitor. So that was a design choice that I made. I like adjustable fixed bias a little bit better. And so that's why I implemented this circuit right here. Coming out of pin 6 of the rectifier, we're running into this bias circuit. My understanding is we've got a diode here, which will allow only the negative waveforms to pass, and then we're kind of rectifying it and sending some of it through the resistors either to ground or to the bias node, which is right here. And this is actually something I took from Rob Robinette's website on 5F6A Tweed Basement Mods, is an adjustable fixed bias, and I found this works really, really well to give me what I need. All right, so let's move forward a little bit. We've got our bias, we've got our rectifier. Now let's move to our B+ smoothing circuit right in this area. What I kind of had done is I basically just took the B+ smoothing from a Tweed Deluxe or a Princeton Reverb and kind of copied that. But because during the discussions, it kind of came out that, why don't you try using some different tubes? And I have a stash of 6AU6 pentodes that I wanted to, we talked about it a little bit, and it seemed really kind of cool to me to use those tubes in my stash. I already had them, and read some reports and some threads on the internet about their performance, and they seemed like a really good choice. So wanted to use those pentodes, but I kind of had a big eye-opening experience as to how B+ step down is calculated and how it works. And so this initial setup here is really not workable with my B+ step down. And the whole reason is because a 6AU6 pentode is going to draw more current than a 12AX7. And if you look at this diagram here, this was taken from Merlin Blenco's website on smoothing. And the idea is that if this red part is our current coming off the rectifier, and it's going to be kind of pulled into each of these different locations, primarily by the output transformer, but then next mostly by the power tubes. Well, a 12AX7 is drawing minimal current, maybe 1 or 2 milliamps. But we looked at the tube data sheet, and the current draw of a 6AU6 was quite a bit higher, and we had factored maybe up to maybe 10 milliamps of current. And so if you look at what I had done, if I was going to run, this is the B+ step down here, if I was going to run, if I were to run a 6AU6 pentode and calculate the resistor drop downs that I've got there, I'm going to end up running negative voltage. My B+ step down going to that pentode is actually going to be a negative voltage, and this was a great application for me to use Ohm's law. And the idea here, and this was really eye-opening for me, is that so what you kind of want to do is it helped me to think about it backwards. So let's look at this 12AX7. So let's say that at this point right here, you want to have a certain plate voltage for your load line consideration. Load line is going to require your plate voltage to be entered, and then it's also going to be your plate resistance, which is typically a 100K resistor. Those help set your load line. The B+ really helps to factor, okay, if this is my desired plate voltage, using Ohm's law, if we've got a voltage drop and we've got a resistance, we can figure out what we need to go, how much voltage is going to be dropped, and we know the current as well. We can figure out how much voltage is going to be dropped. So that was kind of some of the calculations that I did here using Ohm's law as calculator. You can see I was just playing around with some different numbers and kind of came to understand that, okay, so if I want to have, this is a 343 volts going to V1 at the 12AX7, well, given your plate current, given your voltage, and then given the other variables here, your plate resistor, all of that works together to set your variable. So basically, I was kind of working backwards, and I said for my 6AU6 pentode, I was looking at the data sheet. Let's see if we can pull that up here. The data sheet for the 6AU6 pentode, and again, this is all kind of a preliminary estimate. It's not necessarily meant to be a hard and fast This is exactly what is going to happen. It's just kind of our best guess. Here we go. Here's our 6AU6. And so, a lot of this is talking about, here's our maximum pentode connection is 330, so we don't want to exceed 330 volts on the plate. Then we've got some nice ideas here for a preamp valve running as a Class A amplifier. We're looking at about 200, maybe 250 volts here. So that was kind of my target, is about 250 volts DC on the plate. And so if we've got 250 volts on the plate, we also have this graph down here, which gives us a entire circuit for our amplifier. And you can see here's our EBB at 300 volts. That's pretty close to what we're looking at. And this gives us all the different calculations that we can have and what kind of gain it'll put out. And it was just a really helpful way for me to kind of structure how I got everything. So I had to make quite a few adjustments at this point in the circuit, but it was really helpful. Again, using Ohm's law, if we've got, if we know all the variables, we can figure out what our B plus is going to be. And because the 6AU6 pentode is drawing more current than a 12AX7, I had to drop these resistors to be a lower value to be compensated for the fact that I'm drawing higher current. So again, this is V1 of my schematic, and I did make a lot of changes from here, but just want to talk as to what didn't work or what did work. Next, I'm also using a cap can. You can see I've got 40 UF, 20 UF, 20 UF, 20 UF. This is the JJ cap can, which I chose it because in my tight chassis, it was going to be really convenient to have all my filter caps in one location. When I say JJ cap can, I'm talking about this guy right here. It's just one little cap can that you can put into the chassis, and it's very, very convenient to deal with. So those are my values. Now 40UF is probably pushing the 5Y3 a little bit, but I think it's okay. Then I also wanted to use a choke, and then like I said, my dropping resistors are going to be adjusted based on the Ohm's law calculations of voltage that I wanted to achieve. So that is how I tweaked my power supply. Let's kind of keep moving here. We've got our 6V6s. All of this was basically taken from like a deluxe reverb. Again, our negative bias is going to the grids, creating a fixed bias circuit, which is what I kind of prefer a little bit here. Then I wanted to include this, we've got our coupling caps, and we got this Vox cut control, which is an idea I got from Rob Robinette. And the idea here is that you are actually using a variable resistor here, a pot, and then this cap. And what happens is that frequencies above a certain point set by this cap, so very high frequencies, are allowed to pass through the resistor based on the amount of resistance. And because this is post-phase inverter, joining these signals together, they're going to be out of phase, and they will actually cancel one another. So we're canceling some of those high frequencies out. Then we've got a cathodine phase inverter taken from a 5E3, and the reason I chose that is just because we've got the 6AU6 preamp pentode, and then a driving tube to kind of help with the, make sure I've got enough gain to drive the power section. I didn't want to do a more common split long tail pair phase inverter, which requires 2 triodes, and just wanted to use the simpler cathodine phase inverter from a 5E3 type amp. Now, to accommodate for that, I'm actually using a pre-phase inverter master volume, which almost serves more to cut down the signal that's hitting the phase inverter, so it does not generate some of that yucky distortion, but from overloading it too badly. So that kind of helps keep it in check there. A cool modification moving back here, this is my 12AX7 in the middle of the circuit driving into the phase inverter. We've actually here on the cathode, we've got a switch that this is from Rob Robinette, this is his negative feedback idea. So we've got a 25 UF fully bypassed in one position, and then if you switch to the other side, it actually removes the capacitor, which will lower gain and increase headroom, less clipping. It's going to be harder to clip. And it also connects a negative feedback line to the output transformer secondary side. And so again, going to clean the amp up and really provide a higher headroom, better clean experience so it doesn't get quite as mid-rangey and congested like a typical tweed voicing, to just provide some versatility. Next in this section, I have a volume control and then also a mid-range control. This is the Framus mid-range control, also from Rob's website. And the idea here is that I really like a blackface style circuit, and the tweed voicing can just be a little bit too hot for my tastes. then our gain control with a treble bleed. Then here's our 6AU6 pentode. These are, again, just values that I took off the data sheet to kind of as an estimate. And the only really cool part here is I do have a bass switch, which will go from a 25 UF bypass cap, which is full frequency, full bass, to a 1 UF, which would be much tighter, much lower bass. So this was my V1 of my schematic. Now I want to show version 2, which is the more updated version. After I had built the amp, I kind of played around with it and made some of these changes and kind of wanted to document them, and let's just kind of go walk through it. The bias circuit worked great, didn't change any of that. My capacitor is good. I did use this choke. I think it actually was a 4 Henry choke was the one I used. But then these dropping resistors I changed to 4.7K, and the idea was that, I felt like 10K I was dropping a little bit too much voltage, and just the 4.7K was a little bit better for what I wanted to achieve here at B+4 for my pentode. Alright, so then moving backwards, I changed the values of these C9, C10 coupling caps a little bit to 0.02. I like a little tighter bass, so that was a little change that I made. Got these 2 bias resistors, which I had forgotten. That's good. Then here on the phase inverter, I actually changed this just to be the stock 5E3, which basically has the pre-phase inverter master volume preset at max. The only reason I did that is because I actually ran out of holes in the front for reasons you'll see later. But I would recommend the pre-phase inverter master volume. I think there's really no reason not to do it. At maximum, it is as if it were fixed, but then you just have the ability to dial it back a little bit and clean up the phase inverter just a touch, so I would recommend it. Then I did keep this negative feedback mod, which I really like, and I may experiment with this 56K resistor. So then, moving back into this section between the 12AX7 and the 6AU6, this is really where I did some big changes. You can see I added a treble bass, and then this really is kind of a mid control, but I put a tone stack in here, and actually I took out the high cut Vox cut control here, and then over on the bass switch I changed that a little bit so that it basically either has the 25 UF cap or nothing to just do the resistor. And my reasoning here was actually on initial setup, I was actually getting a pretty hot signal. So I wonder if the 6AU6 maybe drives the signal a little bit harder than a 12AX7. And getting a tone stack in here just seemed to suit the voicing of the amp a little bit better for my purposes. Make it a little bit more of a cleaner amp, more blackface-y, given some of the values I've got in here. So we've got our treble, our bass, basically blackface values except 500K pots. And then actually my mid control, I'm labeling this as a raw control because I actually put a 250K pot, which is very high. A blackface Fender has like 6.8K of resistance here. Like a 10K or 25K pot is more standard, maybe more Marshall-y. But 250K is really heavy, and basically what that means is once you get past maybe 7 or 5 or up to, from about 5 up to 10 on the control, you're actually defeating the tone stack. So it's similar to having a switch in here that would actually defeat the tone stack entirely. So, when you get to 0 to 1, it's a very blackface tone. Maybe 3 or 4 gets more of that Marshall mid-range tone. And then from about 5 and up, you really start to defeat the tone stack. And it really increases in volume. It becomes more raw and just more tweed-ish, which I really like this type of a tone stack for tone shaping and just find it works really good. So then back to my 6AU6, I basically have all these values kept the same, but I will probably be experimenting with them a little bit just to dial in, the plate resistors here and the grid over on this side, and just because this is a little bit of an atypical tube, and it's possible that some of these atypical values might be ideal. So anyways, this was the schematic that I ended up going with finally in the end. So if you have any questions, I will post it if you want to take a look at it. But overall, definitely had a lot of experimentation and just a lot of, once you get the power transformer is really the core building block, and then you make some design choices after that. What kind of bias do I want on my power tubes? My B+ step down using Ohm's law to get the desired values of voltage at each of the nodes. what type of tubes can you run based on your power transformer, and and then really the preamp. You can run whatever preamp you want. And then the phase inverter for me was more about optimizing the amount of triodes that I had available. And so all of that really led me to this stage where I've got this amp circuit that I really like. So that was kind of the design choices and the circuit choices that go into this. So please let me know your thoughts or questions down below. Next stage, I think we'll go ahead and take a look at the amp, and we will listen to some tone clips. So hope you guys enjoy this. I'll see you again soon. Bye.